Hello, let me begin by introducing myself. My name is Fransiskus Leonardus Molan Korohama, graduate student at Universitas Sebelas Maret, Surakarta, Indonesia. Today, I am pleased to present my research titled Analysis of Irrigation Water Distribution based on water balance and fullness of key factors in the Batuplat irrigation area. This research focuses on addressing irrigation challenges in the semi-arid region of Kupang City, where water scarcity is a major concern for agriculture. I will present four main parts in this presentation. One, introduction; two, methodology; three, result; and the last is a conclusion. The Batuplat irrigation area is located in Kupang City, which is classified as a semi-arid region. It experiences prolonged dry seasons and is vulnerable to drought. According to recent studies, Krisnayanti et al. 2023, such regions require climate-adaptive cropping strategies to ensure agricultural productivity. This study emphasizes the use of climate data and water forecasting, predicting water availability and crop demand, and implementing precise irrigation scheduling. Governance also plays a key role, as Gui et al. The year 2024 explained. Collaboration with water users and the government is crucial for effective irrigation infrastructure. The objective of this research is to find the most suitable irrigation distribution pattern using water balance analysis, key factor fullness evaluation, and geospatial mapping within the Dendeng watershed. Second is a methodology. Study location: Boniquare, Kupang City, located at 10 degrees 12 minutes 7.456 seconds south and 123 degrees 35 minutes 55.352 seconds east. This ware irrigates 140 hectares, of which 90 hectares are currently functional within the Batuplat irrigation area. The catchment area covers 18.15 square kilometers. Geospatial mapping is used to delineate the catchment in the Dendeng watershed and to analyze the hydrological response. Evapotranspiration. Penman modified method using tertiary station data like temperature, radiation, humidity, wind. Water availability. The FGMOC method is used incorporating rainfall data from Sikumana station. Evapotranspiration, soil and groundwater data. The soil type is Cambisol. Water demand. Based on evapotranspiration, effective rainfall, crop needs like rice and corn, percolation, and land preparation. irrigation distribution pattern, also known as the key factor. Key is defined as the ratio of the available discharge at the weir to the required discharge at the weir. The range of key factor values is from 1 to 0. A value of 0 indicates a situation that is very prone to drought, while a value of 1 indicates good conditions. Similarly, when the key factor value is between 0.75 and 0.5, it indicates drought condition. In this case, it is advised to manage water distribution at the tertiary channels level. Meanwhile, if the key factor value ranges from 0.5 to 0.25, water distribution should be carried out at the secondary channel level, which also indicates drought-prone conditions. The findings show that evapotranspiration greatly influences water availability. During periods of high evapotranspiration, from April to December, water availability drops, which affects irrigation supply. Conversely, when evapotranspiration is lower, the balance between water supply and demand improves. Next, we will see water availability. Bonic Ware's discharge peak in late February with 0.18 cubic meters per second. The total annual availability reached 1,301,625.20 cubic meters. Based on the fourth simulation of the rice-corn fallow cropping pattern selection scheme, the following irrigation water requirements were obtained. Among several cropping simulations, the rice-corn fallow pattern simulation 4 was selected. This pattern requires 1,214,064.44 cubic meters per year. A water deficit occurred from late December to late January, with values of December 2nd equals minus 0.01, January 1st equals minus 0.01, January 2nd equals minus 0.05. The key factor fullness during this period ranged from 0.83 to 0.66, indicating moderate water stress. To address this, rotational irrigation is recommended, especially at tertiary plot level, ensuring water needs are still met despite shortfalls. The cultivated area includes 90 hectares of rice in the first planting season, 2.77 hectares of corn in the second. The last part from this presentation, in conclusion, the first, the total annual water availability of Bonic Ware is 1,301,625.2 cubic meters. Second, the total annual water demand for the rice-corn fallow cropping pattern is 1,214,064.44 cubic meters. And the last, the water balance in simulation scenario 4, with the growing season starting in early December, indicates a deficit occurring from the end of December through the end of January, specifically December second period negative 0.01, January first period negative 0.01, and January second period negative 0.05. In this water deficit condition, the value of the K factor ranges between 0.83 and 0.66. This indicates that the distribution of irrigation water can be scheduled alternately on tertiary plots so that water requirements are still fulfilled. The cultivated land area includes 90 hectares of rice during the first planting season and 2.77 hectares of corn in the second planting season. This study offers insights into adaptive irrigation strategies using a combination of climate data, hydraulical analysis, and crop simulation. Thank you very much for your attention. This is the end of my presentation.